Yes, what did you do?
Do I have another?
Of course, they didn't give me
Any grabs or?
Oh well.
Okay. Now where did I put that at? Oh, shit, there it is. Okay. Let's see. So let's see if I have. Oh, sorry. There you go. Like the x squared minus 8x inside for this to work. Gross. So what's the inside function? What do I let u equal? Yeah, that's the part that's stuck inside something else. So if I let u equal x squared minus 8x, what's du? Don't forget this poor little j. It's important. Do I see that in there? Almost, right? I just have to introduce a constant. So if I want to put a 2 here, I better put a, yeah. If I want to take the golden statue, I better put a bag of sand. So the overall, I didn't do anything, the boulder doesn't come get me. Okay, so now this, what is this? 2x minus 8 dx is du. So all this is du. And then this is cosecant squared of u, yeah. And what's the interval of cosecant squared? Negative. So I mean negative 1/2 cotangent squared. No, not cotangent squared. Cotangent of u, which was oh yeah. It's not. So we are. I love this face. Better than this. Everybody cool with that? Those basic integrals you gotta know. Secant squared comes from tangent, therefore cosecant squared comes from negative cotangent. Those are negative. How do you check that? So if you have time, you go back and you take derivatives. Because derivatives should be less easy to make a mistake on. You should be able to trust what you do there pretty well. Okay. I mean, is that enough? I mean, my God, that's the basic idea of it. There I go again. There's a problem. I'm just going to use it. In a sea of blood. There's a problem on the practice test that looks like this. This piece of it looks like this. You almost can't go wrong. You could choose this thing for the wrong reason, but what's u going to be? Square root of x. So u is x to the 1/2. What's du? Do I have part of this in there? Yes, absent a constant, which is never a problem. So what constant do I want to introduce inside? 1/2. So what? I better put a what outside? 2. Just balance it. Very chemistry-ish. Trying to balance it. So then this becomes 2 integral. This is e to the u, and this is d. And then that's easy. Cool. Okay. And notice it had another part to it But when you have only one part that needs u sub, you separate it out into a couple different intervals. So you just do this one directly, and then you can focus on this one. It needs more attention. You don't have to keep it as one big function. You can break it apart. Does that make sense, guys? I mean, what was the other piece of that problem? It was like minus, I don't even give a shit. Does this need a u sub to be done? No. So I'm going to break this off into its own integral, because people are always like, well, this needed a u sub, but that won't work if I make a u. No, you don't need it for both parts. Just break that off into its own integral and do it. All right? Break it so you can focus the one that needs help. Break it.
Is there going to be any problems of the averaging?
Yeah, sure.
Yeah?
Yeah. Were you here earlier?
Yes, but you didn't do it like a specific problem.
Yes, I did.
You did?
I'm pretty sure I did. Did I? We did. Well, we can do another one. Oh, look at me spreading the red. All right. So find average value. Do you have to say it out loud as you do it, Jeff? I like it. So what's the general idea? It's the average. Add them all up, divide by how many there are. That's sort of the rough idea. It's more of a making the area into a rectangle and then seeing how tall the rectangle would be. That makes more physical sense, but you can still kind of see the idea of average. So this would be 1 over what? Yeah, 2 pi over 4, so 1 over pi over 2, which is 2 over pi. Integral pi over 4, 3 pi over 4, sine x. Yes, whoops. All right. And then, is that decent? I mean, so it's really just find the area that this talks about, but then divide it by how wide it is. And we're adding on one extra step. Divide by the length to see what the height would be. That's the average function value. So then you get 2 over pi times what? What's this? Integral sign? Negative cosine? From pi over 4 to 3 pi over 4. What's cosine of 3 pi over 4? It's going to be negative or positive? Negative, because it's on the negative part of the x-axis. The over 4 ones are nice. Root 2 over 2, so it'll be negative root minus. And what's cosine of pi? Cosine of pi over 4 is root 2 over 2. So then you get something very interesting. You get the negatives go away. You get 2 over pi times root 2. 2 root 2 over pi. Right? The negatives cancel. You get a whole root 2 on the inside. I don't know. It's neat to me. So for sine from pi over 4 to 3 pi over 4, the average height over that distance is 2 rad 2 over pi. 2 rad 2 is like 2.8, pi is 3.14, so it's less than 1 like it's supposed to be, because 1 is the highest it gets on the interval. The average height then has to be a little less than 1. So that's the average height for the sine function across that interval. kind of idea is directly related to probability. If you went far enough in probability theory, which actually isn't that very far past the first semester of it, you're going to use a lot of calculus. Anybody ever taken statistics? I found a few of these. Anybody statistics? Yes? Okay. You immediately, when you do the normal curve, you get the Gaussian, this beautiful e to the x squared kind of stuff. No, I'm sorry. Your teacher might never have mentioned it, because maybe they sucked, I don't know. But Gauss deserves a lot of credit. He's the one that came up with the normal curve. No, maybe not. No. Normal curve. Okay. It's a Gaussian distribution. The formula is nifty. And since you guys know calculus, you could actually work with it directly.
Notice, I want to point something out. I don't know if I made a big deal out of it. Look at number 6. Do you notice, so number 6 where I first draw the banana, so it's at the bottom of this page, number 6. There's a lot of parts to number 6, so we go. Do you see the points I used to graph it? I mean, I figured out that they meet at 2 and -2. Okay, those are 2 obvious points to graph. And then I graph where they are at 0. For 2 reasons, to get a better sketch and to see who's on top, who's on the bottom. So and the scale is disgusting, and who gives a shit? As long as it's 2, 4, 6, 16, that makes logical sense. 16's up here, 2's down. Okay, that's good. All right, I just love it when people are like 3, 7, 5. Okay, that's not going to come out. All right, so on those, when the rough sketch can be really rough. You just want to give yourself a few anchor points. Okay. So when you find where 2 things meet, those are obviously anchor points. Stay classy, problem. No, not anchor points. If I'm you, I'm going to have my graphing calculator. I'm going to make sure I remember how to put stuff in and get intervals so I can check my work as I go. Checking your work is not a problem. If I see completely wrong setup and then the right answer, that's a little troubling. Everyone's terrible. Anybody? Anything else? You guys are ready? Yes. Oh yeah.
Oh God, he's red.
How did I do this one? I can't remember. Oh, look at it.
There's a couple different options here. I'm curious, what did past Jeff do? Good. Just past Jeff did good. You could make u equal this piece by itself, but see how... And why would I do that? Because the derivative of this is in here. Right? So it's sort of like another level of what you're looking for when you do u sub. Is there something whose derivative is in there also? That's a good candidate for u then. But if I include the 2, does that really change the derivative? Does it really change what du is going to be? No, and that's awesome. It wraps more shit into one little compact thing. So I'm not going to let u equal 3x squared. I'm going to let u equal 2 minus 3x squared. Now, would you get the wrong answer if you did it the other way? No, it's just going to be a little bit more difficult. So I don't want to do that. So if I let u equal 2 minus 3x squared, du is, yeah, negative 6x dx. Do I have negative 6x dx? Almost. The most important thing is I have an x. If I don't have the x, if that wasn't there, that was 3, I'm screwed. You wouldn't know how to do this until Calc 2. If you never take Calc 2, you'll never know how to do that. Part of you should be angry about that, but I won't. Too bad. But I do have the x there, thank God. What else do I need in here? Then I introduce a negative 2, so I better negative 1/2 on the outside. So overall, I did nothing. Right, the negatives are not going to chase me. The boulders going to stay. Negatives will still chase me. Yes. So this is, what's this? du. And on the bottom, what is 2 minus 3x squared is u. You can write it like this, or you can write it like this. It doesn't matter. Like this, you can write it like that. And of course, what's that integral? Yes, I heard that. I heard that. Natural log of? Almost. I think I heard it.
2 minus 3.
True, yeah, but what's on it? Absolute values. There's no limit, so I have to put the absolute values to cover my ass for anything. I like it. I like it.
What exactly are the two fundamental theorems of calculus?
Oh, okay. So, f taught 1 is that if g of x equals the integral a to x f of t dt, then g prime equals f of x. That's the one we just did earlier. Of course, if I put something, this is in the wrong place, I've got to flip it. If I put something more complicated, it's going to be a chain rule. So to make this more general, I could do this. There. So now it's more general. So if I have some function of x here, the derivative is going to undo the integral. So that just comes out. Evaluated it there. Then the chain rule has to be done. It's a more general f taught 1. And then f taught 2 is the thing we keep using over and over and over and over and over and over and over. Integral a to big f of x dx equals big ass f of b minus big ass f of a. Right, how do we do it practically? We find big ass f of x, and then next to it we put a to b, and then we plug a b in, we plug an a in, and we take a difference. Right, that whole thing. Can't like it. So that's f taught 2, remarkably important. This one is quickly forgotten, but without this, I actually couldn't get here. And this is the one we use to death. You even forget that it's a fundamental theorem. You just use it all the damn time. Sorry, this is really pretty for me. I was just admiring it. Like you could read everything I wrote. It's nice colors. You're like, yay, if you do that more often, Jeff. You don't have to sit there staring at me. If you're ready, you can head out. It's fine. I don't have a prison. Yes?
What is the final gonna look like?
I will give you a practice final with an answer key.
Is it gonna be like a lot longer?
How long do we have for normal tests? We actually have like 2 hours and
20 minutes or something, roughly, right? The final's going to be 2 hours. So to be honest, the final's going to have to be a little shorter than a regular test. But it's going to cover
Everything.
So what exactly will be on it? Well, it could be anything. Sorry. So what exactly should you study? Everything. Every damn thing we did.
Can you do 4-H, please?
Oh, so that one's a lot like this one was.
Right? So, same thing with the U and with D. Alright.
Yeah, so e to the 3x minus 6x.
So that's the U.
That's the u, because I can see e to the 3x minus 2 has a chance to match that guy's derivative.
Alright.
I'm not going to make it e to the 3x minus 6x to the 4th power, because that derivative would have so many parts, and I don't have a lot of parts sitting outside.
Yeah.
Yeah.
Shift are these in this pile? Or?
No, right. I like it. You've made a pile. Yes.
Are we going to be able to make test corrections till the test 4?
Of course. Yeah. You'll have until the day of the final. It's always the day of the next test, and that'll be the next test.
There's the half circle in the second question on the biggest rectangle. So I solved it as a sine of 45 degrees
Ooh.
that way. But my calculator is in radians, not degrees. So if I would have had it in degrees, it would have been right. Would you have counted that as right?
I might have given you something, but like I always like to say, this is calculus class. So if you don't use calculus in a problem, there's a very good chance you're doing something wrong. Some of the things are like find using geometrical formula. But if you're not using calculus on something like that, you're probably not going to get all the points. Yeah.
Will you be in your office tomorrow at 12:30?
What is tomorrow? Wednesday. That's when I normally get done with my class. So that's if you hang out, you might be able to catch me. Because I go there, upload the video, and then I head out. Yeah.
I'm a class rep number 1.
Yeah.
Okay, so